Hello everyone, this is Unofficial Sendo. Today I'm going to talk Leetcode 416, partition equals subset sum. As always, please support me by subscribing my channel if you like my videos. You can find a complete problem list in video description below. Let's look at the problem first. We're given a number of array and we need to find two subset. Actually it's just a subsequence. So both sum of subsequence should have same sum. Actually we can convert these problems to find the subsequence in this array, and that subsequence sum should be the whole sum of array divided by 2. So take first example. For instance, so the total sum of array here is 22, and so we are going to find a sequence which find its sum should be 22 by 2 equal to 11. So we want to find subsequence has the sum for this target. So it's turn out the result can find two subsequence. We can only need to find one. So each one sum are all 11. Same thing for the second examples. Here the total sum equal to 11. However, 11 multiplied by 2 is not equal to 0. So we are not able to find any subsequence to divide the array. Each one has the same integer sum, right? Okay, let's look how we solve this question. So here I'm giving array, for example, 1 3 7 3. Its total sum is 14, and we need to find a subsequence which target sum should be equal to 7. So we can use any brute force method. We can construct all subsequence and find one. That sum is 7. For example, we can find 1 3 1 7 1 7 3. In any combination, we can get a subsequence. So in turn out for this example, we can find the subsequence either 7 or 1 3 3, which is meet our target. So we'll return true eventually. So if you take a look for the computation complexity for this method, to construct all subsequence, we find each index use or not use to construct subsequence, right? So when we design use or not use, will be the 2, and for each index is below the 2 power of n, assuming n is length of nums. So how we optimize the method? So it turns out we can use 2D dynamic programming. So we have a declared 2D DP array here. So I means when we stop iterate to the i's index, and we only look at the subarrays construct by from 0 to I, and j means our target sum. So if we explain the whole 2D array into a table, we will find for the range of j, we only need to iterate to the target sum, which is 7. So the row here means each index. Then let's find what's the patterns for these examples. For initializations, I always given the 0 index as all true. So 0 here basically is a padding. Of course, we cannot find any subsequence which sum is 0, because for this example, for these problems, all the numbers are positive integer. So here I'm giving all as true as a padding to help later calculation more convenience. So for initialization, of course, if we start with empty array, we cannot get a subsequence which sum is equal to any of these values, so all should be false. Then if we start at 0, so we will from previous row we are looking for how we propagate the whole basically we call this status of dynamic programming array. So since current value is index 0 and current value is 1, we can get a subsequence which sum is 1. So basically we were looking first from the first index from the last row and plus current values. So we will move from here to here, so we will change this will be true. Since everything here slots is false, so we cannot get any more true values from the rest of the slots. Then let's move on for the next index. So that value is 3 here. As previous, we start from previous row and first index. So 0 plus 3 is 3. So we can propagate the value from here to these slots, makes it true. Then we can still looking for this one. 1 plus 3 is 4, so we propagate the 4 cells here. Then for this one particularly, because from the previous row, its substitution can already achieve the same sum, so we can still keep these two status here. Then let's move on the second index, which is 7. So we start from previous row, first one, 0 plus 7. We can update the value here, 7. And we can do any of them because any of them we plus 7 is out of the bound. However, we need to still keep the previous true values from here, and from here. Lastly, we are looking index 3, which is 3. We start from here, 0 plus 3 makes this as true, and 1 plus 3 makes this as true, and 3 plus 3 is 6, which is the unique value here convert from false to true. And also we propagate the true from the next row. Eventually we only need to check this one, right? Whether I have any subsequence equal to 7 as we iterate all the index. Then the dynamic programming progression rule is as here. If let's make the current row and the target is true if the previous one is true, or from the previous row we can add in the current values to this j is true. So this is the 2D dynamic programming solution. So actually we can doing more advanced optimization using 1D dynamic programming. It turns out we can use the rolling array, which is rolling from the previous value. Here we define our dynamic programming as 1D subsequence. These times we will propagate the row reversely from the columns. Let's see how this does. So as always, we still initialize the array as 0 index set true, other place as false. So what we do is we from the last sum we're looking for the back one. For example, for the 7 here at 0 index, we are looking 7 minus 1. So for this 707 slots, we are finding whether the previous 7 minus 1 is true. Unfortunately, this is false, right? So here we can update this as false. So next, also false, because 7 minus 1 is 5, and it's also false. Let's keeping adding here, keeping adding here. Then next will be different. So we're looking at this one. So basically we're looking for previous row and 1, the current sum 1 minus 1, which will be 0. Here, because this is true, so of course this is true. Right. So in this way, we are updating all the cells in the second row. Then let's start with the next row, index 1. And then we start from the back. So right now, the first index is 3. We are looking for 7 minus 3, which is 4. So it's still false, right? So we putting it as false. 7 minus 3 is false. 5 minus 3 is 2. 2 is still false. We can be false here. Okay, so right now 4 minus 1. Let's see. From this slot, 4 minus 3, which is 1, previous row, this is true. Right, so we can update here as true. The same 3 multiplied 3 is 0. It's also true, so we put true here. 2 minus 3 is minus 1. It's out of the range, so we're still keeping the false here. 0 minus 3 is out of range. However, we'll do the same as 2D programming. We'll keep the this answer is true if it's true here, because in previous row we already have subsequence sum is equal to 1. Then next row we'll start from the back, and the value we're looking for is 7. So 7 minus 7 is 0. It's correspond to this one. Since this one is true, we'll update this true, and other are false. And we also maintain the true as well. Next, for this index, so it's 3. We are looking at 7 minus 3 is 4. 4 is true. 6 minus 3 is true. 5 minus 3 is 2. It's still false. 4 minus 3 is 1. It's true. True, false, true. Then we're done. Right, so eventually we are looking for this value. Whether it's true or false, it's our final return. So in this method, we can obtain the propagation rules when the current sum, we need to make this true if the talking sums, actually this is a typo here. Actually this should be j. If j minus minus I equal to true, so dpj is true. Right. Okay, so let's see how we implement code for this 1D dynamic programming. First, we obtain total sum, the whole array. If the total sums cannot multiply by 2 equal to 0, we return false to save the later computation. We obtain our target sum by divide by sum to 2, and then we declare our 1D DP array. We padding 0 here, so we need to plus 1. Then we make the DP0 as true as always. Then we have the double for loop. We start from 0 index to the end of array. We start from the back to 0, and we apply our propagation rules here. Then eventually we will return the end of the dynamic programming array status. Then let's look at the complexity here. If we assume the length of nums is n, and the target sum is m for the particular input, since we have 2D array, right? So, since we have 2D for loop, so our computation will be n multiply n for two for loops. Since we declare 1D array for the dynamic programming, the length will be the target sum length, so the space will be bigger of m here. Alright, so this is the all I want to talk today, and please provide any suggestion and comments to make video better, or if you have a specific problem you want me to talking about. See you next time.